Welcome to my channel Class Winner by Shri Shyam Books, All India #1 skill books publisher.
All right, today we're going to be scientific detectives. We're diving deep into the liquids you see every single day to solve the mystery of mixtures.
Have you ever really stopped to think about it? Salt water, muddy water, you're just mixing stuff into water for both, right? So what's the deal? Why do they look and act so completely different? Well, the answer is some seriously cool science that's hiding in plain sight.
You see, the big secret is that they are all mixtures, but they are not created equal. The real difference is happening on a level so small you can't even see it, down at the particle level. So let's grab our virtual magnifying glass and zoom way, way in. To crack this case, we're going to line up our three main suspects. We've got the true solution, the suspension, and the colloid. Each one has a totally unique identity. And trust me, by the end of this, you'll be able to spot them anywhere. Okay, time to meet the crew. We're going to break down what makes each of them tick, and even see how you could whip some up with stuff you probably have in your kitchen right now. First up, the true solution. Now, you can think of this one as the master of disguise. It's a homogeneous mixture, which is just a sciencey way of saying it's all perfectly and evenly mixed. The particles, like salt or sugar, are so incredibly tiny and so completely dissolved that you can't see them at all. And you've made these a million times. Every time you stir sugar into your coffee or tea, boom, the sugar just seems to vanish, right? It creates this perfectly
Like, comment, share, subscribe.
clear liquid. That, my friend, is a true solution.
Next up, our second contender, the suspension. And this one is pretty much the polar opposite of a solution. It's heterogeneous, meaning it's an uneven, kind of chunky mix. The particles are big, they refuse to dissolve, and you can literally see them just floating around in there. Making one is super easy. Just imagine grabbing some dirt from your yard, dumping it in a jar of water, and giving it a really good shake. You can see all those individual bits of soil swirling around, can't you? They're mixed in for sure, but they are definitely not dissolved. And finally, we have our most mysterious character of the bunch, the colloid. Now, this one's the real head-scratcher because it lives right in that middle ground. It usually looks smooth and uniform, kind of like a solution, but technically, it's a heterogeneous mix. Its particles are bigger than a solution's, but they're still way too small for you to see. Just picture mixing something like cornstarch or an egg white into water. You get this cloudy, kind of milky liquid, right? You can't see the individual particles, but you can just tell something's different. It's not crystal clear like salt water. That's a colloid. All right, the introductions are over. We've met our suspects. Now it's interrogation time. We're going to put them through three simple but really revealing tests to expose their true identities. Okay, let's dive into this. First up is the transparency test, and it's exactly what it sounds like. We're going to see how well light can pass through each of our mixtures. Are they clear as day, or are they hiding something? And check out the results. The true solution is completely transparent. You can see right through it, no problem. The suspension is totally opaque. Those big particles block all the light. But the colloid, now this is where it gets interesting. It's translucent. Light gets through, but it's all scattered and blurry. That is a massive clue. All right, on to test number 2, the filtration test. We're going to pour each of our mixtures through a standard filter paper. The big question is, are the particles small enough to sneak through the holes, or are
Like, comment, share, subscribe.
they going to get caught? And would you look at that? The tiny particles in the true solution, they just waltz right on through the filter. But the big, chunky particles in the suspension, they get stopped dead in their tracks, leaving behind a residue. And our sneaky colloid, it slips right through, just like the solution. It's trying to pull a fast one on us again. Okay, for our final test, we're going to do absolutely nothing. Yep, we're just going to let them sit there, completely undisturbed. This is the stability test. Will the particles stay mixed up, or will gravity eventually win the fight? And this test really seals the deal. The true solution is rock solid, perfectly stable, it never changes. The suspension, though, is totally unstable. Just give it a few moments and all those heavy particles give up and sink right to the bottom. But the colloid, it's a real trooper. Its particles are just light enough to stay suspended pretty much forever, making it surprisingly stable. So, after putting our suspects through the ringer, the evidence is all in. Let's pull everything together and lay out the final verdict on what makes each of these mixtures so unique. And here it is, the big reveal, side by side. A solution is transparent, can't be filtered, and is super stable. A suspension is opaque, you can filter it, and it's unstable. And the colloid carves out its own special category. It's translucent, can't be separated by a normal filter, and it's stable. See? Each one has its own distinct fingerprint. So what's the one big takeaway here? The entire mystery, the whole shebang, boils down to just one thing: the size of the particles. That's it. Super tiny particles give you a solution. Big, chunky particles give you a suspension. And those Goldilocks, just right particles in the middle, that's what makes a colloid. It's really that straightforward. And this isn't just some abstract science experiment. Now that you know the clues, you're going to start seeing these mixtures everywhere. Let's take a look at where you can spot them in your everyday life.
So let's circle back to our original mystery. The clear salt water is a solution. The cloudy muddy water is a suspension. And the milky liquid we talked about, that's a colloid. But they're everywhere. The air you're breathing is a solution. Salad dressing that you have to shake up is a suspension. And so many common things, milk, fog, even Jell-O, they all have that unique colloid fingerprint. So there you have it. You are now officially a mixture detective. You have all the tools you need. So I'll leave you with one final case to solve on your own. What kind of mixture is blood? It looks pretty uniform, right? But what happens when it's left to sit? Can it be filtered? The answer is actually a bit more complex than you might think. Something to chew on.
Thanks for watching. Don't forget to like, comment, share, subscribe.